morning, everyone. Hoping you can hear me well. This thing is working? Great. So thank you for coming this morning. eBay has recognized the value of APIs in its early days, and it has been following API-based integrations. But unfortunately, at that time, it was early 2000-ish. The APIs were only available for third-party developers, so internal applications really didn't see the value of that extra hop through an API. So internal applications were all based either having a direct access to the database or doing event-based integrations. I will share with you today eBay's journey to microservices and what was the triggering point of recognizing the value of microservices and having the company's commitment of truly transforming its monolithic code bases to a microservices-based. Good morning. So just out of my own curiosity, like how many people here are coming from a company where microservices have all been figured out, the company is doing well, like transitions has been done, or the company was building microservices from beginning? Okay, great. We have a lucky developer, a lucky engineer. How many of you are working for a company that is in the middle of transition and is kind of like figuring out? Okay, kind of most of the people. I guess that's why you're here, to kind of hear eBay's story. And then how many of you are just thinking of starting a transition and still not sure about the microservices value? Okay, a few folks. So I will try to cover both aspects of why eBay thought that microservices were valuable and also like how we were approaching the transition. I'm not sure if I'm going to have much of an input for the person that is coming from a company that has all figured it out, but I'll be happy to share the experiences after. So my name is Snezana Sahter. I have been working for eBay since 2004, which makes me a teenager in eBay's years. And I've been a part of the core product architecture team. I started as an engineer working on the first site launches, China site launch, India site launch, and then eventually transitioned into an architect's role. So I've been kind of part of that transition pretty much since beginning. So a little bit of setting up the context of what eBay is and what type of use cases we're dealing with when it comes to microservices transition. So eBay is a marketplace in a marketplace business, which means it's enabling buyers and sellers to come on the platform and transact or trade. The type of use cases are typical for e-commerce. What you're going to see, like browsing for inventory, adding to cart, going through checkout, making a payment from the buying side, and then from the selling side, coming and creating your offering or creating what we call listing. Also then being able to fulfill an order and to respond to any kind of questions that the buyer has or for any post-transactional processing. The scale has been pretty much an interesting challenge from the technology perspective, just the fact that the site has, at any point of time, has more than 1 billion active listings, has 300 million users. Most of the traffic, or a lot of the GMV, 61% today is really coming from mobile. So that has been the shift that eBay has seen in the past 5 to 7 years. So explaining how we got there and how we realized the value of transitioning to microservices. So eBay started with a fairly small and monolithic code base, which was called V1 and V2. V1 was Perl. V2 was nothing but rewritten stack in C++. It was not much of a distributed. It did not scale. So there was a series of meltdown experiences in, again, early 2000-ish that eBay realized that they have to truly move to distributed systems and distributed applications in order to scale. At that time, it also recognized the value of distributed databases. So with the V3 and V4 platform, which was a Java-based platform, it did solve for its scaling solutions. And at that time, it was not really one monolithic applications. It was the set of distributed monolithic applications. So each application was handling a certain type of use cases. So you would have my eBay application, UItem application, registration flows, etc. So what was really the issue then? Why eBay recognized that it has to move to the microservices? Because like I said, the scaling was in a way handled whatever was the business needs on the horizon. It was that type of architecture was able to scale. So it was really at the point where the traffic from mobile native applications was on the rise, and it was like rising from 10% a year after year, starting in 2011, 2012. And at that time, if you were a mobile native application developer, you were pretty much treated as a third-party developer. So trying to build a buying application and not really having direct access to the database and not having services that are exposing capabilities and data, and having an application that is really sitting outside of the data center where the database is, did not really make the development easy. So what the first releases of the native eBay's native application was doing, they were actually accessing trading APIs, the public APIs that were first built for third party. It was at that time then recognized fairly soon that this is not the way to move features and to enable native application development to move forward. And at the same time, it was a clear demand from the customers that they wanted to be able to access eBay Marketplace's site across devices and not just coming to the web application. So it was really at that point that eBay recognized, so it was 2012, 2013, that there is there has to be a company's commitment to start moving towards the services. So up until that point, yes, it was also the web services were being something interesting to build. There were these sporadic services being built, but not in the coordinated and organized fashion, and kind of making sure that the functionality and capabilities that the services cover are really enabler for building all kinds of experiences out there. So the one other challenging thing that keeps making this transition even more interesting is the fact that all of these generations of services coexist. So even today, our native application is still, to some extent, using trading APIs, while it has primarily moved towards the internal services that are exposed for access outside of the data center. So let me tell you what was then the approach for how we kind of pushed eBay's development into the microservices world. So the first, like trying to do this in a coordinated fashion, it did require recognizing certain standards. So why standards when nobody likes to impose, especially developers doing the building the services are not necessarily in favor of certain standards being imposed onto them? Well, it is really more from the consumer's point of view, from the developers that are building the applications that will be consuming services. What the early generations of native application development experienced was dealing with all kinds of variety of how the errors are being handled, how the HTTP status codes are being set, if they're trying to get an item information, it was the representation was coming in one way from one service, and then it could be something relatively like similar but still different coming from another service. So even the terminology was not necessarily unified. So it was actually killing their productivity trying to understand, like if an item price coming from one service is exactly the same item price that includes, for example, shipping, if it's coming from another service. So this is where the set of standards and the set of architectural patterns and the model was becoming crucial to make sure that these services are really usable from applications development point of view. I will talk more about what standards we recognize that were actually the most useful in applying this for internal services, as well as for public APIs. So the architectural model and the patterns. So why was this important? At the beginning, it's like, so when at the very early stages of doing the services development, it was at some point becoming so popular to build services that even the product managers and business folks would plan to build a service, some kind of a service, even before it would reach engineering project. So by the time it reaches engineering project, trying to rewind and kind of like reset the expectations of what services need to be built was actually becoming extremely difficult, because in their mind it was already said that we need to build this type of a service. So, and the services scope and purpose and the function, what it was doing, it was again varying from one service to another. So some teams wanted to build just one service for the whole domain. So like you would see, for example, if you take my eBay, you would just see all kinds of functionality behind one service, like trying to get past purchases, trying to get past listings, trying to change something on an order, trying to ask seller questions. So you could start seeing all of that behind one service. The other example where some teams felt that it's a good idea to build a service in such a way that it just exposes the data that you can get by querying one or two tables, right? Whatever sits in that one sharded physical host, well, we can just build a thin service layer on top of our persistence layer and start exposing our table structure. That obviously, again, is not the best way to model for services, because you start really exposing your persistence layer, and persistence layer has been in eBay kind of the way it is, like user tables, item tables, again, since like the beginning of 2000. So it's not something that if you're looking to build new features, you actually want to hide that structure and start kind of expanding beyond the few set of tables. The other set of services that I have seen was the services that are really mimicking the user experience. So whatever the data that you need to see on the page, this is what the service would return. Again, did not matter whether it's coming from if it's a user information, item information, etc., but it's just whatever the experience, the UI needed at that time. So again, with such a variety of doing the decomposition, it was, at some point we were figuring out that there are these patterns emerging, and I will speak more to what patterns we recognize, but that kind of helps us set the focus, like what the purpose of the service should be, and kind of define the scope, and even to some extent define like what you should be seeing in the interface, like what kind of a resource representation, what kind of functions you should be seeing in a service. The model. So why was architecture model important? Again, the business was changing faster than our underlying model was able to accommodate. So some original assumptions that were made 12, 13 years ago, obviously, like, were no longer supporting the latest needs. One typical example that we are still figuring out how we can actually fund it and do it is the fact that our sellers are asking for multi-user access to their accounts. So they don't want to share username and password with their employees. So like what they actually have today, they have to do today. So they were asking to enable creating multiple username and passwords on top of their seller accounts. So our current user model, it really fuses all of that together. So the credentials and the account information, it's actually all coming as representation is really one thing that we're calling a user. And it obviously is represented as one record in a table called eBay users. So trying to now break that and differentiate between the credentials, or what should really be a user as a login, versus an account information, the managing the relationship between the business, for example, or individual with eBay, and keeping track of all of the transactions, all of the listings, and all of the purchases. Just trying to undo that, it proved extremely difficult. So this is again where expressing that model, so it's not just about putting a service on top of the existing model. We're actually trying to transform that model as well as we are building services, even before we are transforming the underlying persistence layer. So first about creating that isolation, so that like the consumers that are using the services start speaking the new model, start really differentiating between the user and account as two different things. And only once that's achieved, then we can actually start transforming the persistence layer underneath without really creating the major 3-year kind of a project where nobody can build any other feature than just doing this. So services portfolio. So this is something that, like, if you're a developer that's building an experience or building an application, if you need a certain feature or you need a certain data and there is no service for that, it was becoming extremely difficult to influence the roadmap of the team that actually owns the data. Sometimes it was even like the data would data ownership would not be exactly clear. So it's like even figuring out who should build the service to expose this data or to expose this feature was also not always clear. So doing the services portfolio management in a coordinated fashion where like understanding the gaps, what services need to be built in order to expose the capability that are either third-party or first-party or second-party needs. This is what the service portfolio management is about. The other point was making sure that there are no overlaps. Obviously, overlaps are costly, also confusing from the consumers, and not the best way then to manage the evolution of those APIs and interfaces if you have overlapping functionality between services. So governance and advocacy. So in order to truly like bring the company as one behind the standards and patterns model and the services portfolio, you really need, we figured out that we need some type of a governance, even though it was not very popular term, and it's not something that, again, developers are looking for in terms of more processes that are put up onto them. But we were trying truly to make the governance process more of as an opportunity to communicate standards, kind of educate developers that are potentially coming for the first time to the review that the architecture team is doing with the engineering teams. So kind of educating what the standards are, also looking at their model, because the model that the architecture team would come up was targeting the core entities and the entities that are commonly used across applications, but there are tons of other information and tons of other data that we would still rely on the engineering team to come up with the model. So reviewing and going through that design together, it was extremely valuable. And it was in the same time providing the feedback loop for the architecture team to understand like the standards also need to evolve, they need to change, they're not written perfectly in the first iteration. So doing this, not just the governance, but this type of a review process, it was also a feedback loop back to the architecture team to understand if things need to change. And then having foundations really enable to the development to jumpstart, so they don't have to worry like how the consumers to their service needs to be authenticated, like making sure that there is the platform team, our infrastructure group provides that type of work where the consumer can register, can really express what authorizations it needs, and then without the feature developer actually doing any work, it's all taken care of by the framework. So security, tracking, rate limiting, logging, all of these really become the foundations that you don't want the feature developers to spend time on. So eBay was doing its own homegrown solutions, but there are products out there that can help jumpstart that. As well as the really important aspect was having a repository tool where the contracts and the interfaces can be registered. Part of the process, the review process, was also to make sure that the contract and the changes to the contracts are recorded in the repository, so that the discovery process between the consumer and service providers really becomes self-service rather than consumer teams figuring out who they need to talk to, organizing tons of meetings, and then still not having all the information. So the attempt is really, and honestly, it's still an ongoing effort to make sure that the repository is complete and the documentation is auto-generated based on the contract that the service provider has to create. So services standards. So some of the first iterations of the services standards, actually there was, I think, almost 20 of them. So they were like a lot more granular. And there were some that were really more like a patterns, not necessarily standard specifications. So over the course of a few years, we kind of collapsed and we tried to concentrate around certain aspects of the services development. So the first one being, I think, what any feature developer first has in mind is the contract, is the interface definition. So how do you really approach creating the service interface once you understand the set of use cases and once you start really recognizing or building your model? So that modeling part, the conceptual model, becomes really the baseline for interface definition. So how do you recognize resources? Do you need to recognize the sub-resource? Are you going to just recognize the type, containers within the resource, or there is a value of recognizing the sub-resource? That becomes what the interface definition is really trying to guide developers, and it was really based on probably 200 plus use cases that we have been seeing up until the point of interface spec definition being created. It's also, we did follow REST, and I already got that question before the session, and I'm sure there will be more questions towards the end when I opened for a Q&A session. Did we follow pure REST or why it's REST-ish? So we've decided that for eBay, or for at the point where we were, going for a more pragmatic approach of expressing interfaces was the best choice for eBay. So it's all, at the end, it's all about choices. And whether you want to go with the pure REST or whether you want to like try to, again, ease the transition. And also like the developers who are previously used to building XML-based and proprietary formats, that they're used to build RPC-style services and the WSDL definition, using WSDL as a way to express interfaces. Now they were supposed to start moving towards the REST. So our way of recognizing where HTTP verbs are not always necessarily the best way to describe semantic of what an interface is trying to do, we did introduce custom verbs. So for example, register as one of the verbs under the user account business process service would actually say that the account is supposed to be registered, because it would actually use register as a verb at the end. So it would be still post as an HTTP method, but there would be more semantic expressed through the verb, which is present in the path. The difference between this register and just post on the user is that there is more than just creating a user account at that point. And there is more, like a loyalty program is being created, there are risk checks that are being done to prevent certain fraudulent behaviors. So we felt that if the verb, if the HTTP, like I said, if the HTTP method verb does not really express the right semantic, it is okay to use verb. So we are always like shooting for the resource style and HTTP using HTTP methods, but if in some cases that doesn't work, then we are leveraging custom verbs. So for the error specification, so it was again one of the really pain points from the application developer's point of view, how having services really dealing with the different ways of expressing errors. So creating one common structure of expressing errors, also like differentiating between when to send a warning and still treat it as a successful response versus when to send an error. It was something that error specification would define. Semantic versioning, so the trading APIs, or the legacy eBay APIs, were perpetually backward compatible. So the changes over the course of last 15 years were always keeping the contract backward compatible. What that turns the interface into, it's a fairly complex and very cumbersome interface to consume, because you will see pretty much like the whole history of features that were at some point released to the site, not necessarily successful, being pulled back, but the interface still has those elements. And then also as the model was evolving, then you could also see the transformation in the interface. Like, so some fields just didn't even make sense anymore, but again, they still have to be there to treat the interface backward compatible. So with the new set of services, we did want to enforce versioning at the point where it doesn't make sense, like to keep the contract backward compatible. It was actually recommended and required to create a new major version. We were following just the usual semantic versioning with major, minor, and patch or build versions. Minor versions were not in the control of a consumer to request for a specific minor version. So from the consumer's perspective, they could like choose which major version they're looking to integrate. And only at the point where all of the consumers are moving from the previous version into the next version, which was up to the consumer's schedule and not necessarily always enforced by the service provider can deprecate the older version. So only at the point where there is no more consumption. That is, in a way, also proving somewhat challenging because of the native applications that are having all kinds of variety in terms of their own versioning sitting on the devices. So it's not always easy to kill the traffic of the native applications that are coming from their own previous stacks. So that has kind of proven still a challenge that from the service developer's perspective, you have to maintain potentially multiple major versions. So service layering pattern. So I can mention that we have recognized and really tried to predefine how to approach the scope of the service and the purpose of the service. So starting from the what on this slide looks like a bottom layer, infrastructure layer. So these are the services that do not have marketplace-specific models. So these are the services that pretty much any company could potentially use. So they are the services that are providing logging, rate limiting, they're providing consumer authentication and authorization following OAuth spec, tracking, like user behavioral tracking. So this set of infrastructure services could potentially like use even a different protocols, so not always, or they're not necessarily always REST-based. So leveraging gRPC or other types of protocols to really improve the performance is critical because they typically have to operate within 3 to 5 milliseconds, sometimes even less SLAs. Entity layer is the set of services that are really encapsulating our core entities. So this is like truly trying to change the behavior of every application just going directly into the database and accessing a table. So not just like reading table, but also writing any table, including user, item. So any application before entity services had the ability to really read from the user table, or read from the item table, and also change user table and change the user state and change the item state. So the entity services were really trying to encapsulate that access. And it was really then first understanding the access patterns, like that has proven difficult to know how to really build an entity service, but that was something we had to bite the bullet and really put the first set of interfaces out there and then start getting the feedback on did we really make the right assumption of what data information the consumer really needs from these tables, and then really trying to separate what goes into the user entity versus what should be really sitting somewhere else. Because over time, the eBay user table has evolved into this set of columns that were being leveraged by other domains and other functional areas just because it was easier, and it really enabled a good performance to access everything in one shot when that domain has to produce information. Like, for example, feedback score. So feedback score is a whole another functional area of how our consumers, like buyers and sellers, are expressing their satisfaction or dissatisfaction with the transaction. And capturing feedback score was really convenient to manage it in the same record as the eBay, as the user account information is. So the services, the user service, would, for example, attempt to clean that up. So the information that is exposing will no longer have feedback information. So that poses a set of challenges, which I'm going to speak towards the end of the session. The other thing that entity layer was supposed to enable is then once we have the consumer accessing this information through the set of entity services, then we would actually change the model of the persistence layer. So while the new model is what's being reflected in the interfaces, the underlying persistence layer, we would actually then be able to truly change it. So the features I was talking about, enabling multi-user access to eBay accounts, then we could actually start bringing that new persistence layer. But with every application really accessing the same table, it would be really extremely difficult to change that underlying structure. So business process layer. So these are the services that are encapsulating more complex verbs on the site. So if you're talking about registration, if you're talking about how a user can become a seller if we're talking about how a listing is being created, so it's more than just providing a product information, it is also providing the shipping information, it is about providing the parts of the, like completing the seller account onboarding. So there are multiple steps that a user has to do in order to truly create the listing on the site. So encapsulating that whole process and still making it look like fairly granular or fairly simple from the consumer point of view. If you're just saying user/register, right, that tells me that it hides a lot more functionality, but it looks like one action from the application's point of view, once all of the information is collected. And then the register can actually return the next action that the user has to do. So it enables this set of interactions and guiding the user, the UI application of what next information has to be presented to the user, or what next set of information the user has to provide. So the other examples of the business process layer, checkout obviously is being one of the most complex, because again, it's more than just creating an order, it's actually doing pricing, checking inventory availability, then actually decrementing inventory availability. That all happens behind the checkout process. So recognizing this as a separate layer also enables us to enforce a certain dependency direction. So we did not want to run into a situation where any service can call any other service, because dependency management becomes extremely hard. And if you cannot manage the dependencies, that means you will run into the availability issues as well. Because if one service start either like running slower or start timing out, then you would not even be aware of what kind of impact that can create under the site. So doing the dependency management and trying to establish the dependency direction is really one of the crucial points of going, like doing the microservices as a major architecture paradigm. So at the early stages, we did recognize, so it took some time, it took several years to recognize, yes, we need infrastructure services, we need this entity, and the business process services. And at some point, the application developers were still complaining. They would come back and say, well, now I have to still call like 5 other services just to get all the information I need. If I'm a native application developer, that means I'm making all these calls over the network, and it's really creating a poor performance for my customers. So that was one. And the second challenge that the application developers were complaining about was that the data that they're getting back is not necessarily the most consumable way for presentations, because the data was in a canonical representation. If you get the price, you get the amount, and you get the currency, but you don't necessarily get the string that is represents the formatted value of the amount with the currency. And then that same type of formatting had to be repeated not just by native application developers, but also by web application developers. And then there were like several stacks where the same kind of development had to be repeated. The other problem was then the consistency. Sometimes the information would be displayed in a slightly different way depending on the application. So trying to shoot for that consistency, trying to solve for that orchestration, and trying to prepare the data so that it's really consumable by the presentation stack, that's what the experience services were then about. And it was really a controversial topic for eBay. I think it took about 2 years to present the idea, to discuss the idea if this is really a right way to go. Like, it seemed like an oxymoron. You're talking about the experience and you're talking about the service, right? And trying to fuse that together. But a couple of POCs were built, and it did turn out that it was a good, useful concept. Then we were hearing that other companies like LinkedIn and a few other companies were actually trying a very similar concept. So relatively recently, there was a wide agreement that yes, we want to continue with building experience services. We will still see how that goes and where that leads us, because they are really tied to the presentation, and then we'll see what kind of a price we'll have to pay for introducing experience services layers. But at this point, they do seem to resolve the issues that application developers had. Now, the public API layer is either routing or really transforming the the underlying terms to the rest of the world, to the outside world. Third-party developers, second-party developers were going to really see public API as a way of integrating with the eBay's functionality. So the public API layer is really supposed to isolate and hide the inner workings and sometimes even the organizational structure that imminently does influence how we are doing the services decomposition. Because in one service should be owned by one team. And sometimes, like I said, organizational structures do get into the way of how we are doing the services decomposition. So public API layer, again, it's supposed to hide all of that and truly present the most consumable way, consumable interface from the third-party perspective. So eBay last year released the first set of this new public API services on the buy side and on the sell side. So these services are really available for consumption, and the documentation is available on the developers portal. So one agreement that was kind of hard to reach is that why shouldn't the first-party developers access public APIs? And because traditionally, like I mentioned, native application developers were using public trading APIs. So why shouldn't we allow, like if you're already spending this effort, and the documentation was really good, like the native app developers really like the documentation that the public APIs would have, because obviously there is more focus and there is a whole team that is just dedicated to writing the documentation for public APIs. So the thinking was that, and this is what, again, we have seen in trading APIs, and especially when the native apps were using legacy trading APIs. The need of application, like internal application development to evolve and to support every new feature that is coming to the site is different, and it comes at a different velocity than the velocity of change we can impose onto the third-party developers. So for third-party developers, it requires a lot more communication. It requires a lot more rounds of gathering feedback, doing beta, making sure that the feedback is incorporating, and then really doing the general release. For the internal services, then we don't have that type of a barrier. So we can actually introduce new features without like spending cycles on gathering feedback from external developers. So trying to use public APIs, it slows down. They actually, like you would, as an internal application developer, you would not be able to get all the features and all the latest capabilities. And the second problem is that, again, that isolation and that abstraction of the internal model that I was talking about, then it starts leaking towards the public API. Because the internal application developers and the needs of our own user experiences are different than what the third party may have. So it was one of the reasons why we wanted to enforce that the first-party apps cannot call public API layer. So I already mentioned the dependency direction. So that what that really means is that the upper layers can access the services from the lower layers, and the other way around is not allowed. So the services from the lower layer cannot access the services from the upper layer. The other thing is that the first-party applications are not, their calls don't have to always go through all of the layers. So again, the pragmatic approach was that build a layer only if it really adds the value to the whole use case. So it doesn't mean that every use case has to have a representation or has to have a service in every single layer. So that was, again, the way of, I would call it a pragmatic way of making sure that we don't always kind of follow only one principle only, and we kind of try to accommodate different needs that application developers have. So the first-party application could actually call a service from any of these layers if it needs to. So what were some of the obstacles that, even with all the structure and with the standards and patterns and with the governance and reviews, and what are some of the things that we are still hearing from application developers, from service provider developers building services, and from the teams that are actually consuming services? So one common thing is like what I call it just another flag. So it kind of reinforces that convenience of the shared data integration. So when the project comes, they need to add a new property, like there has to be a new data element that the user will provide. It has to now go all the way to the database, and obviously like some other functionality may need to expose this information. So even though like microservices are supposed to enable speed of change, it's still engraved in people's mind that it's just easier to add another flag into eBay users table. So as long as you can find the space and you can find the available what we have bit flags, very convenient way to pack a lot of information in a single column. So as long as you can do that, it's still seen as a fairly a lot less effort from the development is needed to just reserve the flag and start immediately writing into that column and writing into the eBay user record. So especially when the project is under timeline pressure, there is an expectation that they need to deliver next month. So going through all of the service interface changes, going through the reviews, it's compared to just adding another flag. It's kind of hard to explain why in the long run, like adding these flags are actually killing our business in the sense that we're not able to transform our architecture and our implementation to accommodate for the business changes. So this remains, I think, the ongoing challenge, and it just requires a lot of education. And at the point, I think, where we reach the critical mass and we truly encapsulate the access to the database behind entity services, then I'm hoping I won't be hearing just another flag argument that why we should be doing that rather than changing the service interfaces. So one service. So again, we did solve with the experience service layer the complaint that the application developers had where they have to orchestrate across sometimes like between 5 and 10 services to just get all the information that they need for the experience. So the experience service are really modeled after the UI. But the domain services are following more canonical approach, right? They're supposed to reflect the conceptual model. And yet there are still sometimes these arguments that when a business process service needs to call an entity service to get an information, they again just want to get all of the information in one shot. So they want to get the user information, they maybe want to get the feedback information, all of it just from one service. So that again remains something that it's influencing the decomposition, and we're looking into ways of how we can optimize without really creating one, like, or managing one strong typed interface for exposing the information that potentially a domain business process service needs. So we're actually exploring GraphQL, we're exploring a few other options of how we can enable the consumer to achieve the performance. It's really addressing their performance concerns. So how we can achieve that without creating this custom composition of the services, which will really blow out the number of services we will have in the services portfolio. So the whole idea is that entity services are these like a building blocks, like Lego blocks that you can then use to create all kinds of combinations on the business process side. If we start putting that into the entity services, we will be killing their reusability as well across. So kind of figuring out how we can accommodate that, that's still an ongoing work for the architecture team. Versioning is hard. So again, the tendency is that if they just need to add another property, or even if that property is overlapping with an existing one, it's still easier to add it in the backward compatible fashion rather than release a new major version. So recognizing that point where truly a new major version is needed versus like continuing to change the existing contract in a backward compatible fashion has proven somewhat difficult, especially that from the service provider teams, managing multiple versions in the same time is still seen as costly. And really the solution for that is doing a lot more automation than we are doing today in terms of how we're doing testing, how we're doing deployment, how we're pushing to production. So at the point where that is being resolved, this type of issues should in a way should go away, because creating another major version and having the right set of monitoring tools to manage and understand that all of the versions are up and running and providing the performance that they need. If you have the right set of tools and the right set of infrastructure support, it should not become such a big effort from the service development teams. And a few more obstacles, and then I'll be answering questions if you guys have any. So coexistence of several API generations. So while we are doing the services in a new way, REST-ish way, we still are dealing with legacy trading APIs. We are still dealing with all kinds of generations of services that existed in eBay. So we're talking still about SOA-based services, RPC style. We are talking about the previous generation of REST style before standards came. And now with the standards, it actually did change of how we were approaching the design. So the coexistence of the services, these different generations of services, means that one call chain, one dependency chain may actually have multiple generations present in that one call, which starts breaking the standards along the way. So if the implementation of the standards, like I mentioned, is really supported by the framework. So the developer, the feature developer does not have to worry about it. But if their service is being called by the service from the previous generation, that service may not have that kind of a support in the framework that supported, like a V3 or SOA framework that supported that older generation of the service. So this is where it becomes a challenge of how do you rely on the standards when you know that not all of the calls will always be able to follow the standard. So one way of how we're trying to deal with this is to kind of, at least for the major use cases on the site, that we push for migrating them onto the latest stack and push for migrating them onto the latest standards, so that we don't have to deal with this kind of like breaking standards in the way on the during the call chain. Common types. So this was something where we tried early on to recognize one definition of a user and one definition of an item that will be reused across service interfaces, because in theory, reuse is good. Well, it turned out that managing those common types, first, the definition of common type was really a superset of every possible thing you can think of when it comes to item and listing information. So it included product information, it included shipping options, it included return policy. So it even included for example, statistics that the item has, like how many purchases, how many transactions, how many views an item had. So it was a superset of item common type definition, and it proved challenging, even that there was an implementation and some services started adopting. It was really difficult for that service and for the interface to express what exactly they truly need, because it was always dragging this whole superset of definition of what an item is. So it was a very similar story for the user as well. So after several iterations and kind of figuring that we cannot really manage the common type, and that this is not the right way to express or use them in the contracts, we kind of abandoned the idea of having the common types, and we are really only following down to the base types, which is just the very few key elements that are common across interfaces, but really do not express anything marketplace specific, and we actually call them base types. So I'm talking about an amount, I'm talking about how we express dates. Address is something that the base type also defines, but it's really nothing as complex as user or an item that we are really trying to manage as a common type. Instead, what we are doing is either telling the services they should go by reference, so they should not, especially if they're from the entity service layer, that they should only be expressing the data that they are producing and that they own. And if they are pointing to the user, they will be only pointing to the user ID reference. So the identifiers are commonly managed and kind of recognizing what the identifier every service needs to use, and because even that, like legacy, means also that you're dealing with actually multiple identifiers in the system. But we are trying to express in the contract what type of user identifier has to be present. So we are saying that instead of using a common type for a user, the service should really be referencing to a user. The other thing we were trying to do is to have a common dictionary. So if an experience service is expressing, like is returning the user information in the form of a module, that module definition is going to be common. So there will be one shared repository of common definitions on the module level, but the implementation may still be specific to the service implementation. Design reviews slow me down or are costly. So that's another thing that we are constantly under pressure that when the project is dealing with the deadlines and we do not necessarily plan ahead, just having that one more meeting or one more session where they're explaining their interface and where we're asking them to make changes to be compliant with the standards is proven that like the developers do perceive it as something that's holding them back and putting more pressure onto their schedule. So that really requires first the company's commitment, and requires that evangelism and the training, and making sure that in every team we have a developer familiar and kind of knowing standards in and out, so that their service development really doesn't have to go through several iterations just to adopt the standard, so they can actually get it right the first time. So that's one way, but it kind of continues to be the pain point that kind of between the architecture and engineering team of keep like a contention point of pointing back to the architecture team that we are the ones slowing down the development. So even with all of these obstacles, I'm a strong believer that eBay is on the right path of going to the microservices architecture, and I think it's really a necessity for eBay's applications in order to respond to the business needs that are kind of coming on the horizon for the next 2 to 5 years. Recommendation would be that any company thinking of going to the microservices should create the structure and should create the set of patterns and the model that work for that company, and kind of like enable it going for the more pragmatic approach that it may actually take several iterations to eventually go to the more purist ideals or the principles, or maybe actually never get there, but as long as this is adding value back to the company, I think that would be quite acceptable. So I will be taking questions now. I think I have 10 minutes left. So, question?
You said earlier that you kind of like had a REST-ish interface and you created your own verbs and stuff. Does that also apply for the public API, or were you
Yes.
using a different approach?
Yes, it was the same approach for public APIs. So if you look at the latest, what's available in the developers documentation, you will see that there are some, especially for inventory API, there are some examples of the verbs. Especially that, again, even though the model is something new, we're talking about SKU-based item, we're talking about the inventory item group, which is reflecting the listing, to some extent is still bounded by the underlying legacy and the legacy model. So it's not always easy to express when you're trying to say, I have a SKU item, and now I want to actually create it, like transforming it into the listing that's available for purchases on the site. How would you do it? So it's not about creating the listing, because that's another system doing it. So we introduced the verb is called publish. So publishing inventory onto the site means actually creates the listing from the selling model, but from the inventories API, it actually looks like a publishing to the marketplace. So that's one example that I think it explains why post may not just be, or put or whatever, may not be the best way to express what's really happening. Thank you. Question?
Yeah. One question according to the layer model. You explained that the second and third party apps only have access to the public API layer.
Right.
But the enterprise service, like the first party apps, do have access to all the layers. So do you find it complicated or hard to manage when you're allowing access to such deep layers like the infrastructure layer or the entity layer, when you wanted to change something in the back end?
Yes, so it's true that when you're adding a new property on the entity layer, then trying to push that change throughout of the set of consumers is somewhat of an issue. But again, it was a compromise between making sure that like the application developers can move relatively quickly without always waiting on because if you would always push them through all of the layers, you would have to see that change reflected in all of the interfaces. If it's one service that is making a change and then you have to have a consumers adopting it, it's kind of like you have to choose the less of the efforts that it's taking. So I think that's still yet to be seen. Was that the best approach, or should we always like have them go through the business process? But we wanted to also make sure that sometimes if the application developer is trying to do a composition that hasn't been seen before, that they're able to do it without waiting for the business process service. So recognizing the business process sometimes lags, depending on what the needs are on the application development side. So that was the reason why we felt it was like okay, or again, it was more of a pragmatic approach to allowing them to access entity services so that the consumers can also dictate their own composition without always being expressed through the business process services.
Thank you.
Hi, question?
Get where you are today, did that also require a lot of organizational changes, like building up dedicated API teams?
True. So it did require organizational changes, and then organization, again, is still what is heavily influencing our decomposition. But, for example, the team was formed to be dedicated to create public API layer. So we have both examples where buying APIs are created by dedicated team, and then the selling side of the public APIs are still created by the selling domain teams. And so we're kind of trying the both models and see which one works better, and then there will probably be more organizational changes coming along the way. Thank you. Any more questions? Hi, go ahead.
When common data types, you say every microservice has its own data model for user, for items, for product, and so on. This gets you a lot of mapping efforts, I would guess.
So the domains, the entity services, and we were actually recommending that they go by reference. They would expose the user IDs only and not the rest of the user information. It's on the aggregation layer, the composition layer, which is the experience services and the public API, where they may have to, like, they are exposing the user information. And that definition is then governed by the architecture team. So we are working with the experience service developers and with the public API developers to make sure that their definition of the user type is at least looks consistent. So even that they're doing their own implementation, the definition will be common. With the adoption of Swagger, so currently we are using our own internal proprietary ways of expressing contracts. But we are looking, public APIs have already started adopting Swagger, and then we're looking to adopt more of the Swagger even for internal applications. Then we will be looking for having a common definition of a type that can be incorporated into the interface and can generate help with the implementation rather than always pulling the common library that previously used to implement the common type. I hope that answers the question. Any more questions? Yes.
Did you have to work on the company culture in terms of changing basically your IT architecture?
Yes. Yes. So we.
How did you do it?
So I think we're still working on changing the company's culture. That has proven one of the most difficult. Like you see in that obstacle that says design reviews are slowing me down, or why can't I just do another flag? Those are the symptoms of that changing the culture is difficult. And when the team is really under the pressure to deliver their own feature, their own project, it's like they don't necessarily always have in their mind the benefit of all of the rest of the eBay or the benefit of a long term. They're just fighting to really deploy their feature in the next month and making sure that they're responding to the commitments that they made. So that is still a battle that we have on our hands. The good thing is that the company has committed to this and that it continues to invest into resolving the technical debt. So that it continues to invest into pushing from one stack to the latest stack, and that also helps then changing the culture, because then if the developers, if a lot of things are solved for them and they don't have to like deal with those overheads, then they also start eventually seeing some value from all of this. So it takes time. I think changing culture really takes time, and it also means truly allowing the systems and the structure to evolve, that none of the standards may be perfect, or the architecture team should allow for the constant feedback from the teams. So I think that also helps changing the culture if the developers feel like the things are not just imposed to them, but that they can actively work with the architecture team to make changes. Thank you. A question?
How did change the value of your products? For example, you split your development into several parts, like the customer value, the maintenance value, the technical debt. From your version 1 to the actual version, how do you think, or how do you correlate or aggregate the data of the progress? Is there more progress in the customer value writer, or is there still a lot of technical development? What's your view?
How to measure? Are you asking how we're measuring the value of like resolving technical debt versus like building a value for at the end for the product? I think that's proven probably one of the most difficult points, like measuring and like showing that the constant progress is being made. It's either like through the developer satisfaction, so that's one measures, like if we are moving towards the most recent stacks, if they feel like they're doing the latest technologies and that they're like following the latest, not just eBay standards, but industry standards as well. That's one measure of how are we on the right track of resolving a technical debt. The other is like really measuring the scopes that the teams are giving and kind of like the time it takes to bring a new product or a new feature to market. So that's still more of a subjective, I would say, measure. Like it's more up to how the product managers and the business perceives the product engineering groups. So I don't think we have necessarily always the best objective measures, but it's something that we are figuring out how to keep bringing the value. It's also about, like I would say, making sure that we have that commitment is also based on a lot of the influence that we are doing, and kind of like having that buying from the executive team that what we are doing is on the right track. So it does take some of the influence, not just objective measures. Okay, thank you. Any more questions? I think I'm right on time. Okay, thank you so much.